Ceph on Windows, and this session will be English. Our speakers will be Alessandro Pilotti from Cloudbase Solutions and Mike Latimer from SUSE. Alessandro Pilotti is the CEO of Cloudbase Solutions, a company focused on cloud computing interoperability and the main contributor of the OpenStack Windows and Hyper-V components in Nova, Neutron, Cinder, Ceilometer, and Heat since the Ozone release. Currently leading the cloud-based team porting Ceph on Windows. Alessandro lives in Timisoara, Romania, and is a speaker at industry events like OpenStack Summit and OpenInfrastructure Summit, Build and KubeCon. And Mike Latimer manages one of SUSE's engineering teams dedicated to enterprise storage and the Ceph project. He has over 25 years of experience in the software industry with an emphasis of low-level software components, including the Linux kernel and storage subsystems. He also has a strong interest in physical hardware, such as traditional SAM-based storage and enterprise-grade servers and virtualization. He has extensive experience with Xen, KVM, VMware, and Hyper-V, and enjoys performance optimizing these environments. Ladies and gentlemen, please welcome Alessandro and Mike for their presentation.
Thank you very much.
Thank you. Thank you for the warm welcome. Well, I'm going to go ahead and start things off. And I just want to say that Alessandro and I are thrilled to be able to speak to you today. We feel like our topic is very exciting and really is a great thing to inform you on. So I hope you enjoy the session, and feel free to reach out to us afterwards if there are questions. As mentioned, I'm Mike Latimer, and I work exclusively with the enterprise storage team at SUSE right now, where we're dedicated at basically ensuring Ceph is available pretty much everywhere. And Alessandro is a valued partner of ours. Before we get into the meat of the discussion, I wanted to talk a little bit about how we got here. And that is pretty simple. Simply explained, Ceph is a very popular software-defined storage solution that is seen in so many implementations these days. Many of those environments actually also use Windows for various reasons. And so we're hearing from customers and partners and people we pass on the streets that ask us, how do we integrate Microsoft Windows? How do we gain the benefits of Ceph for these Windows-based clients? And up until now, the options have been somewhat limited. You have to go through an Iscsi gateway or a Samba gateway. And we kind of put our heads together, and the Cloudbase guys were aware of this issue. And SUSE and Cloudbase has had a long relationship where we've relied on them to help us in situations where we don't have enough engineering power to dedicate to a particular task. And when given the chance, Cloudbase really jumped at this opportunity and really has invested a tremendous amount of effort towards making this dream a reality. So we'll talk about it now, and I just wanted to publicly thank Alessandro and his Cloudbase team for everything they've done to help us reach the milestones we are today. But
thank you very much, Mike.
You're most welcome. Thank you for the effort. Really, the ecosystem of the Cloudbase and SUSE has brought to Ceph really allows us to get a ubiquitous playing field across all clients that are attempting to use these resources. So in order to explain this a little bit more, we'll go ahead and talk a little bit about that gateway versus native IO model, or in other words, why is this important? Why is this an interesting thing? We'll talk about the Windows driver themselves, kind of the core Ceph components that are provided with these drivers and how to use them. And then Alessandro is going to show us a demo and a test drive of these key commands. So I think we've got plenty to talk about and fill the very short 30 minutes that we have. The Ceph architecture, as you're probably aware, is rather complex. We don't have time to go through the details because there are hours-long sessions that talk about this that are widely available. I would definitely recommend you look at that, look into those if you would like more details. But the quick version is the lowest level of the Ceph architecture, there are object storage devices. And these are effectively disks that are scattered across commodity servers in racks, in storage data centers, things like that. Those disks can be logically viewed as a single storage device through what's called a RADOS block interface. And that RADOS interface serves up this singular logical drive through various interfaces to applications. There's librados that serves up a view of all of the RADOS device. librdb allows us to carve out individual pools of data and serve them up to hosts in a similar way that Iscsi does. So we can serve those up to hosts or virtual machines. That's the common use case. And CephFS is more similar to, say, a Samba or an NFS sort of interface, where you can simply map a drive letter to the storage pool and get access to all the resources there. So there's those three basic ways of tapping into those individual storage devices as a logical unit. If you don't have the ability to speak one of those native protocols, you have to talk to something that does. And in this example here, I've got client machines on the left that don't have any knowledge of Ceph, but what they do have is an Iscsi Initiator on them. And that Iscsi Initiator connects to this Iscsi gateway, which is consuming RBD resources and providing them up, serving them up as Iscsi targets. So the Iscsi gateway itself is natively aware of RBD and where the physical storage is located on which server and which disk. And so there's logic there to support librdb in this case for Iscsi to serve those up, but the clients themselves definitely don't know anything about them. And the main point with this slide is that the Iscsi gateway in this example is effectively a bottleneck. It is a single point of failure. Now, it's worth noting that you can have multiple Iscsi gateways, but the concept is still there's a singular point of failure here. And if that goes down, you're going to have an outage. In addition to just the single point of failure, all I/O has to be channeled through that Iscsi node. And that obviously introduces a throughput bottleneck. And so from a performance perspective, this gateway model is less than ideal. If you move to a native I/O path, here's where things start to get a little more interesting, because we actually are taking librdb and moving it to the client itself. And that brings the knowledge of where on the storage cluster does my data reside. It brings that knowledge to the client itself. And so the client can directly talk to an OSD on one server on one side of the storage room and then immediately talk to another one on the other side of the storage room without a single point of failure in the middle, without all I/O channeling through some midpoint. And you can see that it obviously increases the total number of paths available for the client to talk to the RADOS block device store. And that in turn increases performance. So this native I/O path is definitely more interesting and better for performance and fault tolerance perspectives. I wanted to show a real-world example, and this is something that I drew up based off of talking to customers that were using Veeam as a backup solution in Windows environments. And I swapped the left and right. So in this case, the RBD is on the left-hand side. You can see we've got multiple Iscsi gateways in the middle. Those Iscsi gateways are providing Iscsi targets that are served up to a Windows VM on the right. The Windows machine has multipath enabled on it, and Veeam writes to an E drive that is the topmost level of all of these layers of indirection or complexities in order to write to the Ceph cluster itself. If we were to take that librdb complexity away from the gateway and move it all the way to the Windows VM in this example, you end up with a picture like this. So this is obviously significantly easier to understand. Veeam still writes to the E drive, but that E drive happens to be backed by librdb, which knows how to contact the OSDs directly inside of the Ceph cluster. So you remove a lot of complexity, you remove a lot of points of bottleneck, and you end up with a much more performant and easier to deal with environment. So let's talk quickly about the driver components. We won't spend too much time on this because I know that the demo is kind of the most interesting bit, but there are some things worth pointing out. First of all, the whole package so far, in order to provide this functionality, we do have to build Ceph itself for the Windows platform. And this is important for us to get the RBD executable. RBD WNBD is an executable that the Cloudbase guys have created, which is really the primary tool for creating, listing, mapping, and unmapping images. And RBD.exe, by the way, there's kind of a wrapper to RBD WNBD to maintain that compatibility with what you're already used to for those that understand Ceph environments and are already using it. We also provide something called Ceph Doken, and Ceph Doken is used in conjunction with an upstream project called Dokeny to get CephFS support. And then there's a few DLLs and a few other bits that we consume from the Ceph project itself in order to make this happen. The real magic comes about with something called the Windows Network Block Driver. This is WNBD.sys, and this is basically using a store port mini port model. It's a block driver for Windows that allows us to actually serve up these resources as block devices. We've had a couple of versions of this so far because this effort's been ongoing really for the bulk of this year. The first version was an MBD-based only protocol. And it worked great. It worked just fine for us, but we did run into some stability or performance type of issues. And we now have a new version that is either out or in the process of coming out, depending on where you're getting your sources from. But this new version is it provides a libwinbd DLL, which provides it's an ioctl-based kind of interface. And this says it offers increased stability, significantly increased performance, and that's really the main point why we want to move to this new model. And it's going to be easier to extend in the future. One interesting bit is with this WNBD driver, you can actually connect to native network block device servers. So you'll see that come into play if you're ever testing this and you want to know if it's a WNBD problem versus a Ceph problem. It's possible to test those too. So we also provide a WNBD-client.exe for that kind of testing. And the final point is these drivers they can be WCL certified and signed. I've personally ran them through the HLK, Microsoft's HLK, and performed the testing. We have them test signed, and as soon as we're done with the beta process, we will be WCL certifying and producing those drivers. Just real briefly, as I mentioned, a couple of flavors. This is an entirely done in upstream kind of project in open source. So the Cloudbase repos have upstream branded drivers and an installation program, and downstream, meaning SUSE as a vendor, we're taking those upstream code, performing some changes to them, like branding sort of issues, and that's effectively it. And then we rebuild the installer, which you can see we do offer a Ceph.msi, or in our case, an SES MSI for SUSE Enterprise Storage. And then this acts like any other installer. It puts the files in C program Ceph. It can be automated with PowerShell. It supports window core mode. You can use, you can repair it, uninstall with it, whatever. We also provide a readme.txt file that has a lot of details as far as how to actually get started and use this. From our perspective, from a supportability perspective, we want to support Windows Server 2019 and also 2016. That's the core of what we care about. We have received reports of people using this successfully in Windows 10. It's just not an area of focus for us from a testing perspective. Real briefly, before we get to the demo, after running through the MSI and getting the product installed, you do have to have a configuration file, which is similar to your ceph.conf that you'll see on the cluster itself. You can see some of the main points here. We point out where our run directory is, where the keyring file is, and how to talk to the monitors. Currently, I believe this is still the case, that we require // here, more Unix-style / as opposed to Windows /, but that'll probably be changed in the future. And that keyring can be copied directly from the Ceph administrator's node. So you bring the keyring, you create the ceph.conf, put them all in C program data Ceph, and then you're able to go ahead and use Ceph sort of commands. I'm not going to focus too much time on this because Alessandro will show you this, but real briefly, you can see that we've got an RBD create that is used to create a test image. We can list images on pools, and we can use RBD WMBD to map those to devices that Windows recognizes. And the highlighted area in red, in the RBD WMBD list output, you can see the disk number. That's the disk number that you would see if you bring up the Windows tool to partition disks. You look for disk number 1, you can partition it, put an exFAT file system on it, or do whatever you like with it. But that disk number is kind of important to see. There is also a Ceph RBD service that will remap these images that you set up on machine restart. So any mappings you create or remove, they're dynamically added to a registry key that's specified there. And then when the service comes up and starts on machine restart, you'll automatically get those connections back to the Ceph cluster. And so they are persistent. And they'll be removed once you manually remove them. CephFS is a slightly different beast because it requires using a third-party tool called Dokany. But once Dokany is installed, you can simply run that ceph dokan command that we provided, point out where your ceph.conf is and map a drive, leave that up in one terminal and switch to another one and access your Ceph volume. I think there's a chance Alessandro may show us that here soon.
Yes, definitely.
Okay, great. With that, I want to turn the time over to Alessandro because I know the demo is the interesting part, and I'm looking forward to it as the rest of you are as well. So, Alessandro, please take it away.
Thank you very much, Mike. Okay,
sure.
Time for the demo. So, Mike already gave you a pretty complete introduction about how we implemented the driver, what it is, and everything. So, I will just share my screen. Specifically, I will share one of the VMs that I have ready for this. Here we go. Okay, perfect. So as you can see, I have a Windows Server 2019, and I have already installed on this machine the Ceph drivers. And that this is just because we don't have so much time, let's say, but let's say that the setup itself is really straightforward, so there is nothing much to add compared to what already Mike told you, okay? So as you can see, I have already all the Ceph commands, which are part of the command line interface that we also installed together with the driver. The driver is installed, and the configuration files are already in place for connecting to the Ceph cluster that I have in this demo environment. Okay, so here I'm just showing you where it is. So it's a C program data Ceph, and then ceph.conf, and I have also my keyring and all the other data that we need. Okay, so this is the standard location where you will find that. This is very straightforward. Basically, you just copy the ceph.conf and the keyrings from your Ceph environment, and you're pretty much done with that. I did an RBD list, which means that I'm already connected to the cluster, and I can actually list what images I have there. So next thing I'm going to do the creation of an actual new image. To do it, of course, from the Windows side or from the Linux side doesn't really matter because, of course, I'm connected to the same cluster. So now, at this point, you will see that we have two of them. So this is, for example, the corresponding Linux side. I'm just SSHing into one of the Linux machines connected to the cluster, and you can see that I can see the same identical images. I have a second one, which is called Hyper-V one. I will use it in a separate demo later, but the one that we're going to use right now is called Win1, okay? So the next thing we have to do is to map it locally with this command. Right. This is actually performing the mapping. You can see already here in the background, I keep this disk management windows open to show you how the disks are actually showing up and being removed. You can see that when I did the mapping, this new disk actually came up. It's a new disk because, of course, it's completely empty. So Windows recognizes it. We have to initialize it. We have to bring it online once this is done. It's online right now. And then we can create a volume inside of it. These are very standard procedures that you will do with any other block device in Windows. Okay, so you can see we have it now. You can open it. You can create a file in it. This is an example, okay? And if I unmap it, it will just disappear. I can just remap it, and back it comes. And if I open it, I can see the same file in the same place. So the data is actually persisting and stored, of course, in the Ceph cluster. If I do an RBD WNDBD list, I will see all my mappings, which in this case, of course, consist on only a single one. Okay, so it's very simple, very straightforward. And anytime, of course, I can reboot the machine. There is a service which is called Ceph RBD, which is also basically running, keeping track of this mapping. So whenever you shut down the machine, it will automatically take them down cleanly. And when you reboot, it will also come up with the mappings already in place for you, okay? The next demo we're going to show, it's related to Hyper-V. So there are many use cases where somebody will use Ceph, of course, on Windows. One of them is, of course, to have access to the remote storage stored on a cluster, but also you could use it as the storage which is running behind, of course, one or more Hyper-V machines. So the next demo, it's exactly about that. We are going to create, to begin with, image. Actually, we created already just to spare a few minutes. It takes like a couple of minutes to create it. So, but since we don't have so much time, I prefer to just have it ready. Okay. So the next thing will be to have a QEMU EMG converted image. So this is basically the command that I ran before to create an image. Is basically I'm taking a QCOW2 image, which contains an OpenSUSE image. And from there, I'm creating, of course, the corresponding RBD image, which is called Hyper-V1, which is, again, if you recall from our previous example, it's already there. It's called Hyper-V1. So what we do next, we're going to map it. So it's going to be the same command that we had here, but just this going to be called Hyper-V1. We have a new disk showing up, which is this one. As you can see, it's already partitioned because the content of the disk is actually the content of the QCOW2 image, which we just transferred inside of the Ceph cluster. It's offline. This is very important. I could bring it offline so the host operating system sees it, but if you bring it online, then Hyper-V cannot use it. So it's important that it remains offline. The next thing we are going to do is to create the machine itself. This can be done, of course, from the in Hyper-V from the graphical user interface, or we can do it. Or we can also do it with PowerShell, which is what we're going to do right now. Okay, so you can see a new machine showed up here. It's still off, and most important, it doesn't have any disk attached, because the next thing, which is the most important right now, is to also attach the disk. So this command will simply take a disk and pass through, which is the disk number 2, because number 1 is, of course, in this case, the volume that we attached before, so Win1 in terms of RBD, and then the second one is the one that we just added right now. Okay, so this point is attached. Start VM SUSE1. And we're starting. We can revert back to Hyper-V. And you will see it coming up. So all this data that shows is not local to my Windows machine. It's actually coming straight from the from the Ceph cluster. So this allows, of course, a lot of opportunities. For example, one of them is to use a Ceph backend for Hyper-V VMs in an OpenStack scenario. Another one is, of course, to be able to use Ceph via in a Kubernetes cluster with a Ceph CSI. This is something, of course, we're working on and will be released later on. But it's all straightforward in how it works. So you see, I can log in, and again, machine running on my Hyper-V node, data stored in the cluster itself. Okay, next. I'm going to show another demo, which is related to CephFS. To begin with, I'm showing you that we don't have any volume. So the first thing we're going to do is to create actually a volume. It's taking a little bit, created. You can see we have one. It's called demo one. And the next thing we have to do is to simply tell our Windows machine to now, if I go in the Windows Explorer, I see that I have a new file system which shows up here. So I can create, for example, a text document and say hello from Windows. Also do the same here. And then if I move to the Linux side, the equivalent of Docker is pretty much the rough equivalent of Fuse on Linux. So this is pretty much the same thing that we're going to do here. We are mounting the same CephFS volume on our local Linux machine here. So that will be here. And you can see that I already have, I can already see the same file that we created on the Linux side, obviously because this is, of course, the same file system we shared. So one of the great advantages of CephFS is exactly that you can share data across multiple hosts this way. And I can also do the same. I can create a file on the Linux side, and that file, as soon as I refresh here, will be visible also on this side. So this is extremely useful and powerful. Okay, this is pretty much it for our demo. So I think we showed the majority of the features that we have in place. The goal from the beginning was always to make everything straightforward so that people having an experience on the Ceph side could easily deploy and operate Ceph, of course, on the Windows side, exactly like it would do on the Linux side. And for Windows users that come from a Windows experience that don't necessarily already have experience with Linux and with Ceph, we wanted this experience to be fully integrated in Windows so that they can feel at home like what they would be with any other native Windows tooling. So I can stop this thing here. I think we have still a couple of minutes for questions.
Thanks for the demo, Alessandro. At the end of the day, you've got a working file system, which maybe sounds anticlimactic, but it's actually a big deal to be able to have that working file system shared across Windows and Linux. It's really fantastic. Yeah, I don't know if there are any questions. We do have one more final slide. It's just a summary slide that points out some of the upstream repos and where you can actually get Ceph for Windows. I'm sharing my screen, but I don't know how to actually make that visible. But yeah, we're really excited about this project. It's been well received so far. We're anxious to get more and more people to use it, and certainly we'd love to get feedback and love to get any one of you involved with the project and hopefully bring this Ceph to Windows for your environment as well.
Yeah, as Mike said, everything is open source, so feel free to use it, contribute, give us feedback. More than happy to accept any of those.
Okay, thank you, Alex and Mike, for your presentation. It was a great presentation and demo, and I really found everything I wonder about Ceph on Windows. We have been really looking for this for a while, and I think it will be very useful. And this shows the power of the open community and open infrastructure. So thank you both for very much developing these tools for Windows. I'm looking for the questions, but I think our community has also found everything they wonder about the Ceph on Windows. So thank you both very much for joining us today. And it was a good job, actually.
Okay.
You're most welcome. Thanks for the opportunity.
Thank you
for joining again.
Okay, great. Thanks.